Hi dear ones, what's up? I miss you so much. Welcome to our last science video recording for this year. Are you ready? In this video, we'll be talking about the last two lessons of chapter 8, in which we talked about composition of air pollution, and elements and compounds. Let's go! Most of the time, we take air for granted. We use it to burn fuels for heating, transportation, power generation, and many other things. Sometimes we do think about air since it's essential for life as we know it, right? But what do living things need air for? I'll give you 5 seconds to think about this. 3, 2, 1. Breathing. Perfect. Let's do the following activity together. Let's try to inhale and exhale air. Let's start by inhaling. Take the air inside your body. Hold the air inside your lungs. Exhale. Hold the air outside your lungs. But what about breathing? How does the respiration process happens inside our body? Let's see in the next video.
The respiratory system extracts oxygen from the air, a gas our cells need to live and grow. The respiratory system also eliminates carbon dioxide that cells produce after using oxygen. This process is known as respiration.
Respiration is the process that all living things go through to create the energy they need to live. This happens in the cells of the bodies. The cells take in oxygen. But what is the source of the oxygen in the air? Who put the oxygen in the air? I'll give you 5 seconds to answer this question. 3, 2, 1. Plants, that's right. Use sunlight as energy. They capture sunlight using a compound called chlorophyll. They get water from rain and they get carbon dioxide from the air. The process of taking these three key ingredients and making them into food is called photosynthesis. By photosynthesis, plants release oxygen. People, animals, and plants need oxygen for breathing. Plants need carbon dioxide for the photosynthesis process. But what helps keep the amount of oxygen and carbon dioxide in the air in balance? I'll give you 5 seconds to answer this question. What helps keep the amount of oxygen and carbon dioxide in balance? The carbon cycle. Good job! In the next slide, we'll watch a video done by my friend Hassan Zainuddin from grade 5A. Let's watch it together.
Carbon is important for life on Earth. Every living thing has carbon inside its cells. The carbon cycle shows how atoms of carbon exist within living things. Carbon can be recycled between the environment and all the living things. Carbon enters the atmosphere as carbon dioxide from respiration and combustion. Carbon dioxide is absorbed by producers to make glucose in photosynthesis. Animals feed on the plant, passing the carbon compounds along the food chain. Decomposers break down the dead organisms and return the carbon in their bodies to the atmosphere.
So atoms of carbon are always moving around. and so the carbon is used all over our planet. Some things put carbon in the air, and some things take carbon out of the air. But what is air made of?
Hi, I'm a physics student. Ever wonder what air is made of? Well, I did, so I looked into it a bit. If you think about it, you can feel the wind on your face while you're enjoying a nice view or riding on top of a fighter jet. But even though you can feel it, you can't see it. What's up with that? Well, to find this out, let's get a better look of what air is made of by shrinking ourselves to the size of its building blocks. Ready? So we shrunk ourselves 100 billion times, which is nice, but now we can't see anything. This is because at this scale, we're actually smaller than visible light. Not very interesting for a video, but if we use science, we can piece together our knowledge of the world on this scale, and that way, we can recreate what it would look like. Welcome to the microworld of air. The blobs you see around you are called molecules, and these molecules are what air is made of. The colors aren't real, by the way. Let's get a closer look at these thingies. This one. This is nitrogen. Two of them, actually. We like to write it like this, N2. And these two guys are stuck together like I don't know what. Figuring out how to separate these two is probably one of the most important discoveries of mankind. This is because it enabled us to efficiently create food for plants. And without this fertilizer, we wouldn't be able to feed about half of all the world's population. That's a lot of people. But wait, along with giving life, nitrogen can also take life. This is because it's also one of the main ingredients in lots of different explosives, like TNT, dynamite, and many more. Everything is a double-edged sword. Moving on, let's do some blue. Even though it's so important, it makes up only 20% of air. As you probably guessed, this is oxygen, two of them, so it makes O2. Next time you pass by some plants or algae, even the mushy ones, you should probably tell them, "Thank you for breathing." Why? Because if they don't breathe, we can't breathe. You see, when plants and algae breathe, they release oxygen, which we animals later breathe in. So once again, thank you, green stuff. Also, it's responsible for making matches burn and bicycle chains rust. And without oxygen, we won't be able to explore any other planets in the future. Let's see what else we have here. Now I know you're curious about this weird one. This little guy is called H2O, or as we know it, water. There's so much to say about water that we'll have to leave it for another video, so let's just put it back for now. Aha! Now here's something new to most people. This little pink guy is called Argon. It makes up about 1% of all the air around us, about the same amount as water. It's very useful in keeping certain foods and wines fresh. And it's also used in regular and in fluorescent lighting, and it's even used in lasers, which is always cool. So that's it. There's still some small amounts of other stuff, like carbon dioxide, floating around here somewhere, but for now, we're done here. So let's get back to our regular size.
The air in our atmosphere is composed of molecules of different gases. The most common gases are nitrogen, 78%, oxygen, about 21%, and argon, almost 1%. Other molecules are present in the atmosphere as well, but in very small quantities. The percentages of the other gases depend also on the percentage of water vapor found in the air.
The biggest component of air is nitrogen. It comprises around 78% of the air. Out of the remaining 22%, 21% of air is composed of oxygen. So, nitrogen and oxygen gases form about 99% of air. The remaining 1% of air consists of several gases, including carbon dioxide, argon, helium, neon, hydrogen, ozone, and water vapor. So kids, now you know what air is composed of.
So again, air is the Earth's atmosphere. Air around us is a mixture of many gases and dust particles. It is the clear gas in which living things live and breathe. It has an indefinite shape and volume. It has no color and no smell. Air is a mixture of about 78% nitrogen, that's right, 21% oxygen, perfect, 1% argon, and very small amounts of other gases like carbon dioxide and water vapor. Air can be polluted by some gases such as carbon monoxide, smoke. This pollution is one of the reasons for global warming by causing the greenhouse effect. But what is air pollution?
Air pollution. Air pollution is the introduction of foreign products into the atmosphere that have detrimental effects on living organisms and cause damage to the environment. Vehicles release chemicals in the form of exhaust fumes. These chemicals are very harmful to the environment. These gases also cause acid rain, which is also very damaging to the earth. Many industries release a lot of fumes which are harmful for the environment. Refrigerators and air conditioners release chemicals called chlorofluorocarbons, which over time lead to the formation of holes in the ozone layer. These holes let the ultraviolet rays of the sun reach the earth and thus cause various health problems for humans. Fumes released by weapons are also toxic. Volcanoes, upon erupting, eject tons of smoke and harmful gases. These toxic substances linger in the atmosphere for a long time, causing breathing problems for organisms. Naturally occurring radioactive materials inside the earth sometimes decay, releasing a gas called radon. It is considered to be a health hazard as it causes lung cancer if humans are exposed to it for a long time.
Air pollution is caused by solid and liquid particles and certain gases that are suspended in the air. These particles and gases can come from car and truck exhausts, factories, volcanoes, and wildfires. Acid rain is a form of air pollution. When coal and petroleum are burned in vehicles, electric power plants, and factories, they release harmful gases into the air. These gases combine with the oxygen and water in the air. When the water in the air comes down as rain, sleet, hail, or snow, it carries with it these gases. This is known as acid rain. Acid rain is very damaging to all life forms.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. by designing cleaner power plants and using fewer fossil fuels. We can reduce the number of pollutants that create acid rain.
There are many things we can do to help reduce air pollution and global warming. Filters can be used for factory stacks and car exhausts. Use buses and trains instead of cars as they can carry a lot more people. Walking or cycling whenever you can will be even better. Planting new trees and plants will help reduce air pollution since plants absorb carbon dioxide and release oxygen into the air. Burning fuel is harmful for the air, but using unleaded gasoline will be better.
We should take proper steps to control air pollution. Some of the steps to control air pollution are: we should use public transport more. For short distances, use a bicycle or go by walking. Switch off the lights, fans, air conditioners, televisions, and other appliances when not in use. Always recycle and reuse. Remember to carry paper bags and minimize using plastic bags. Plant trees as much as possible.
Planting new trees is a perfect step to reduce air pollution, since trees absorb carbon dioxide and release oxygen into the air. Now, is oxygen an element or a compound? Before you answer this question, let me remind you of what an element is. An element is a substance that is made entirely from one type of atom. What do you think of the breathable oxygen? Oxygen, how do we write oxygen? O2, good job. So, the breathable oxygen is made of oxygen only, one type of atom. So, it's an element. Elements are pure substances that cannot be broken down into any simpler substances. The breathable oxygen is made of oxygen only. This slide shows the periodic table, which is a system for arranging the elements. The elements are the basic substances that make up all matter, so they are the building blocks of everything around you. Examples of elements and their symbols. Chemical symbols are abbreviations used in chemistry for elements. These symbols consist of one or two letters and are written with the first letter capitalized. Let's see some examples. The element mercury, which is a silver liquid, has its special symbol, which is Hg with the H capitalized. Gold, A-U. What about the carbon? What is the symbol of carbon? C, perfect. Bronze. Is bronze an element? What do you think? No, it's a compound. Good job. Bronze is made of two different elements, which are the copper and the tin. So the bronze can be broken down into two simpler substances. It's not an element, it is a compound. Cu for copper, Sn for tin. Aluminum, Al. Let's look at these different elements and compounds. Oxygen, what is the oxygen symbol? Oh, good job. Hydrogen, H, well done. Nitrogen, N, bravo. Look at the H2O molecule. Is it an element or compound? Compound, good job, dear. Since it's not made of one kind of atom, it has in it hydrogen and oxygen, so it's not an element. It has two different types of atom. What about the ozone? O3. An ozone molecule is made of 3 atoms of oxygen. We have 3 atoms, but these 3 atoms are the same. So this is considered as an element since it's made entirely from one type of atom.
When two or more elements combine, we've got a chemical compound. Let's take a look at the element O, or oxygen, found on the periodic table of elements. Oxygen is just one type of atom. Here we represent this atom with a blue circle. Another element found on the periodic table of elements is hydrogen. Hydrogen is just one type of atom that we can represent with a red circle. Now, let's take two hydrogen atoms. We will combine these two hydrogen atoms with one oxygen atom. This is a chemical compound known as H2O. H2O is better known to us as water. Water contains two hydrogen atoms and one oxygen atom that have been chemically combined. Carbon is another element found on the periodic table of elements. Carbon is just one type of atom that we represent here with a yellow circle. Oxygen, once again, is found on the periodic table of elements and is just one type of atom that we will represent with a blue circle. Let's take two oxygen atoms and one carbon atom. When these three atoms combine, they form a chemical compound known as CO2. CO2 contains one carbon, two oxygen atoms. This compound is better known as carbon dioxide. Carbon dioxide, one carbon atom and two oxygen atoms chemically combine. Chemical compounds, when two or more elements combine.
So atoms make up absolutely everything in the world around you. Today we're going to be using these small molymod balls as a model for an atom. Obviously atoms are way smaller than this, but we're going to use this as our model today. What you can see that I've got here is several different types of atoms. And if we organize them into sections of the same type of atom, we can then call those elements. Now surprisingly, there's only actually 118 elements that have been discovered so far, and you'll find all of them on your periodic table. An element is defined as something that is only made out of one type of atom. So if it contains any more than one type of atom, then it cannot be classified as an element anymore. Check out these examples. Which one do you think are elements and which ones do you think are not elements? Pause the video here, see if you can work it out. The key thing for you to realize here is that it doesn't matter how many atoms it contains as long as they are all of the same type, or in this case the same color. So what you've got is these three at the top here that all contain only atoms of one type. All of the ones at the bottom all contain more than one different type of atom. They all have multicolored molymod balls. The question you might be asking now is, what do we call the three at the bottom? So the top three are elements. They contain one type of atom. The bottom three contain two or more types of atoms. They have different colored molymod balls. We call these compounds. And compounds have to be chemically combined and contain two or more atoms.
Will you have me please classify the following substances into elements and compounds? Let's take a look on the first substance. CH. This substance is made of one atom of carbon and 4 hydrogen atoms. What do you think? Is it an element or a compound? Is it entirely made of the same kind of atom? No, so it has two types, carbon atoms and hydrogen atoms. It's a compound. Perfect. O3. We just saw it in the previous slide. The ozone molecule. The ozone molecule is made of 3 atoms of oxygen, same kind of atom. It's the oxygen atom, so this is an element. What about the third substance? It has silver balls, gray balls, red balls, so 3 different kinds of balls. Do you think this is an element? No, it's a compound with 3 different kinds of atoms. That's right. AU. What is this? This is the symbol of gold. Perfect. It's an element. Last substance. The last substance is a molecule made of made of 13 atoms of the same element. So, is it an element or a compound? Since it has the same kind of atoms, so it's considered as an element. Chemically, table salt consists of 2 elements, sodium Na and chloride Cl. Neither element occurs separately and free in nature, but are found bound together as the compound sodium chloride. So sodium and chlorine combine to make sodium chloride, which is the table salt.
To write the formula for carbon dioxide, we'll first write C for the carbon, and then we have the oxide, that is the oxygen. We can see that we have 2 nonmetals, carbon and oxygen. That means it's going to be a molecular compound. And we also see this di up here. Di, when we see a prefix like that, tells us that we have a molecular compound as well. So we only have 1 carbon, so we leave that as C. And then oxygen, we have the di. That means we have 2. And that's the formula for carbon dioxide. This is Dr. B, and thanks for watching.
Salt water, a transparent bowl, 2 glass test tubes, a 4.5 volt battery, 2 twin wires with alligator clips, colored plasticine, 2 pencil leads. Connect 1 pencil lead to the wire by means of the alligator clip. Then seal the connection with plasticine. Repeat this procedure with the other lead. Fill the test tube with water and insert the pencil leads in them. Be careful not to let air bubbles into the test tubes. Attach the free terminals of the wire to the battery. Do not forget which clip you have connected to the positive pole, that is shorter, and which to the negative one. After a few minutes, you will notice that small air bubbles have developed on the surface of the leads. After 3 hours, there is a lot of gas in the test tubes. However, in the test tube connected to the negative pole, there is double the amount of gas respect to the other. Why? Electricity breaks down water molecules, freeing the oxygen and the hydrogen that compose it. Hydrogen gas, H2, forms around the negative lead, while oxygen gas, O2, forms around the positive one. Every 2 water molecules broken down by electricity form 2 hydrogen gas molecules and only 1 of oxygen gas. For this reason, 1 test tube has double the amount of gas respect to the other.
Electrolysis of water is the decomposition of water into oxygen and hydrogen gas due to the passage of an electric current. This technique can be used to make hydrogen gas and breathable oxygen gas. This technique is also called water splitting. During water electrolysis, a power source is connected to two electrodes or two plates, which are placed in the water. Hydrogen will appear at the cathode when electrons enter the water. So the cathode is the negatively charged electrode. And oxygen will appear at the anode, which is the positively charged electrode. The amount of hydrogen generated is twice the amount of oxygen. As I already said, electrolysis is the process of using electricity to split water into hydrogen and oxygen. The volume of the hydrogen generated is double the volume of the oxygen generated. So we can clearly tell that at this side the hydrogen is produced, and at the second side we have the oxygen generated. And since we know that hydrogen is produced at the cathode, so we can tell that this electrode is the cathode while the second one is the anode. Okay, but how do we test for these gases? How do we make sure that these gases are oxygen and hydrogen? Let's start with the test for oxygen. When you have created oxygen gas, you can do the following test. Light a splint, but let it sit for a while until it almost burns out. When you put the splint in the test tube with oxygen, the splint should start glowing and burning again. If it does, then oxygen gas is present and the test for oxygen is positive. This is because oxygen helps in keeping the combustion reaction alive. But what about the hydrogen? How do we test for the hydrogen gas? A lighted wooden splint makes a popping sound in a test tube of hydrogen. Let's use this slide to make an overview and revise the electrolysis of water. Electrolysis of water is the decomposition of water into oxygen and hydrogen gas. That's right. Electrolysis of water process uses two electrodes. One of them is positively charged and the second one is negatively charged. The positively charged electrode is the anode. That's right. Perfect. What about the negatively charged electrode? It's the cathode. That's right. Which gas is produced at the anode? It's the oxygen. Good job. At the positively charged anode, the oxygen is produced. Okay? And the volume of the oxygen produced is half the volume of the hydrogen. So the volume of the hydrogen is double the volume of the oxygen. So we can clearly tell that gas Y is the hydrogen. Okay? And we're done. Do you still have anything to ask about? Miss Fatin is always available to answer all of your questions. I love you so much. Bye bye.